So we are live. Welcome to another exciting GRE Office Hour. Um, we have a couple questions already, so I'm going to start with S's questions, names disguised to protect identities here. Right. So, um, as you asked about this question, and if you're welcome to talk if you want, but if you'd rather type in the chat, that's fine too. So let's take a look at this one. Figure shows the graphs of the equations y equals bx plus j, um, y equals bx plus j, and y equals cx plus k in the xy plane, where b, j, c, and k are constants. Which of the following must be true? Well, let's always focus on this kind of wording when it comes up, because must be true is a very strong thing to say. It basically means cannot be false. And when they give us that construction, we almost want to immediately go into, well, can I prove it false? So, S, what were your thoughts on this one? What did you try?
Well, I can visually tell that y equals bx plus j has um a larger y-intercept than the other line.
Right.
So that's where I started with this.
Great.
Um,
And what term in this expression is the y-intercept?
that's going to be j.
Right. And then K, of course, is the y-intercept for this other one.
Right. So we
So
know that j needs to be greater than k.
yes, indeed. And so that one is in for sure. And
Mhm.
this one is out.
And we
Then
can
what?
safely assume that through the image, correct?
Yes, and it's a great question because it always says on the test, like, figures are not drawn to scale, but if a point is drawn above another point, you can assume that it is. Now, I don't know exactly how far above it is. Like, I don't know if this is a distance of 2 or 2,000,
Mhm.
but you can assume that J is greater than K. It's a good question. Um, what else can we take from this picture?
Well, the slope
Mhm.
is also significantly greater in the slanted line. So that's going to be B and C variables that we're looking at.
I would say the line is more slanted for sure.
Mhm.
However, is the slope of this line positive or negative?
Negative.
It's negative, right? So B is a negative number.
Mhm.
What about C?
It's gonna be looks like it's positive or neutral. It's
Or is
flat.
going zero, right? Now, again, we get into that, like, well, what is safe to assume? Here's what I can assume. This line, if it keeps going, will be above that line if it keeps going.
Mhm.
And so up to the right, or I should say higher to the right, means a higher slope, a greater slope.
Got it.
And that's why we can safely say that B is less than C.
Mhm.
Um, is that okay?
Yes. Could we also look at this and plug in numbers as another way to solve this problem, or not so much?
We could, as long as the numbers that you plug in, um, let's just say, match what we were talking about, like that J has to be greater than K.
Right.
And that
Got
it
it.
crosses in the line above it. And at that point, you've basically solved the problem.
Right, right, right. Okay, thank you.
Of course. Yeah. Um, great. And so you had another one there, Sarah. Let me see. Um, this was, oh, sorry, two other ones here. So an average question. Average questions are fun. Um, let's see. I'll share that. So, S, what are your thoughts on this one?
I am thinking that um we need to add 150 and 110
Okay.
to know what our total numbers in the lists are. Or well, actually, we know that there's 100 numbers in the two lists, but we
Mhm.
know the average is. So perhaps our denominator would be 100.
Yes, that's right. Let's rewind though.
Okay.
Anytime I'm dealing with mean or average, I like immediately to the side, I write this for myself. I call it this the SNA formula. The sum of the numbers divided by the number of numbers is equal to the average. So we have two separate lists here. Let's start with the first list. 42 numbers with an average of 110. I don't know what the sum of all those numbers is yet, but let's fill in this information just for the first list. So in list A, the sum of the numbers divided by 42 is equal to 110. And so S with the calculator, what does that give us for the sum?
That gives us 46, 20, 4,620.
4620. So that's the sum of list A.
Mm-hmm.
What's the sum of the numbers in list B?
That's gonna be 6380.
6380 because we do the sum of the numbers. I'll call it sum B if I want to label it. The sum of the numbers in B divided by 58 is equal to 150. And therefore, the sum of all the numbers in B was 6280.
Yes, 6380, sorry.
6380. There we go. 6380. What's the sum of the numbers in both lists put together?
That's gonna be 11,000.
11,000 on the nose, right?
Mm-hmm.
And how many overall numbers are there?
100.
So
That
what's the
leaves us with 110.
hold on a second. Something's a little off here. 110, that 42 times 110 gave us 4620, yeah. And 58 times 150 gave us, oh, there's the issue. This came out, at least on my calculator, to 8,700. Is that, can you
Yeah,
double check
I
that?
just, yes, yep, my bad.
Okay, there we go. And I'll actually talk for a second about what the red flag for me there was.
Mhm.
8,700. Okay, so sorry, what's the sum of these two together then?
Okay, so 8,700 plus 4620 is 13,320
320.
divided by 100, 133.2.
Yes. And is that I don't know if you have the correct answer in front of you. Is that the correct answer on this?
Yes, that is the correct answer.
Great. So I'll ask you, and Laru, you're welcome to jump in here too. Why did I immediately go like, well, that can't be right when I got that the average of the of everything was 110?
Because that's less than both of the average numbers they provide us with. Um,
Well, it's equal to this one, right? It's equal to the first one. And Laru wrote in the chat here, should be between the two, and that's the issue. If there's even one number, kind of, if you think of it like a game of tug of war, if there's even one number pulling the average up from set B, then the average has to be greater than 110.
Right.
Okay, any questions about that, S?
No, that makes sense. Thank you so much.
Now I'm going to ask a follow-up question because this comes up a lot. And I know this one was, I assume this one was numeric entry, right? Like you had to type in your own.
Yes, exactly.
Let's pretend that, and this is a complete hypothetical, but again, it happens quite a bit. Let's pretend this was a quantitative comparison question. Quantity A was the what's the average of the 100 numbers in the two lists combined? So average of 100 numbers. That's quantity A. Quantity B is, wait for it, 130. Oops. Sorry, my pen's being a little weird here. Here we go. Quantity B is, yeah, 130. Without doing any work, S, which quantity is greater?
That's 0.130.
No, it's 130.
Okay, 130. Um, quantity B,
Why?
because the average of 100 numbers. Well, actually, we don't. Hold on. Are we using this list of numbers still in this scenario?
Yes. So that's what I'm saying is like let's make this a slightly different question. Everything in the way it's written is the same. So
Okay.
average of 42 numbers is 110, the average of 58 numbers is 150, but instead of a numeric entry, I'm making it a quant comparison. And the quant comparison is what's greater, the average of the 100 numbers in this list, in these two lists combined, or 130.
Oh, I see. Well, if if the average has to fall between 110 and 150, um, that's going to be larger than 130.
Why?
Mhm. Because there's more numbers pulling on the side of 150 and less on the 110 side. Thank
Exactly.
you for pushing me to
No,
answer,
no.
see
Because
that.
this comes up, this format of question comes up a lot.
Yes,
Weighted averages, right? It's like they give
totally.
this list and the other list, and it's like, well, what's the average of all the 100 numbers in the list? And we could calculate it the way
Mm,
we did. That's an
right,
important skill to have, but it saves us so much time if we can just pause and ask, well, where does 130 come from? Like,
right,
why is 130 so special? And the answer is because it's smack dab in between these two.
right.
And one side is, again, pulling harder.
Exactly. Yeah, it just takes like stepping back from the problem and thinking about it. Thank you.
Yeah, of
It's
course.
very helpful.
All right. I think there was one more in your email there. So let's take a look at that. Um, oh, so an essay question. If you're okay with it, S, let's do some of the we'll get to this one, I promise. But I'm kind of in like a math sort of like zone right now. Let's
Yes.
keep all the math questions like in one spot, and then we will do this. Yeah,
So,
unless you have to run, let me
no, no,
know.
no, that sounds great. I'm
Okay,
totally on the same page.
gotcha. All right, so Laru, you sent over a few here. Um, GRE guide algebra section. Great. 6F. Let's pull those up. So this is the just confirming this is the official guide, the bigger book. Um, for anyone following along at home. And it's in the algebra section. Get there. So I'm going to share this on my screen right now. And Laru, you can tell me if I'm looking at the right one. Here it is. Oh, you know what? I think I know this question, and it might be a typo, but we'll take a look. So you said 6F, is that right? Um, this one right here. Okay, great. So the instructions are solve each of the following equations for x. Now, let me start by asking this sort of guiding question. Laru, what kind of equation are we looking at here? What kind of equation follows the form ax squared plus bx plus c? Right, it's quadratic. And that's important to recognize, but here's the other thing to know about quadratics. They're fair game. The test could ask you about them. That's allowed. However, almost always they will give you an alternate route to solve. Now, these questions are like drills in the back of the book, and they're kind of like getting you ready for quadratic questions. However, in quote unquote real life on test day, more likely than not, there would be, several answer options that you could plug in and test. So I'm laying down that baseline first and foremost. There will probably be an alternate way to solve this problem. That said, if we do need to solve quadratics, usually the way we go about it, and Laru, correct me or like tell me if you do it differently. Usually the way we go about it is we factor into a nice like, x plus this times x minus that equals 0, and then we solve. So x plus, whatever times x plus or minus whatever equals 0. And we do the thing where we look for what adds to our C, excuse me, what multiplies to our C and adds to B. And I'm guessing, Laru, that's probably how you solved this one. Doesn't work so good here, though, right? Because you can rack your head like, what numbers multiply to -1 but add to -1? Well, I say like 1 and -1, no, but those add to 0, or then I start worrying about like fractions and decimals, and it gets pretty messy. So what we need to do here is what I call the nuclear option, which is the quadratic formula. And again, I said this at the very beginning, there will almost always be a different way to solve it. Plugging in, testing your own numbers. But on the very edge cases, they could ask you this. It's in the book. The formula is in the book, so technically it is fair game. I will say I've probably seen one GRE question, like a real question, that actually requires you to know the formula, but here it is. X is equal, might bring back some memories, to -b plus or minus the square root of b squared minus 4ac all over 2a. And of course, the a, b, and c refer to this, ax squared plus bx plus c. So in this case, the a is 1, the b is -1, and the c is -1. So let's get to it. Negative b is -1, so 1, plus or minus the square root of b squared, -1 squared, so 1, minus 4 times 1 times -1, I'm just applying the formula here, all over 2 times 1. When I solve this, I get 1 plus or minus the square root of 1 plus 4, because when I multiply all these together, I get -4 times -1. That's +4. So 1 plus or minus the square root of 5, all over 2. So you get your solutions, whatever they are, but they're not pretty, right? They don't factor nice and easily. Really, the only way to solve this one would be to use the quadratic formula. Laru, let me know if that's all right. If so, I'll keep moving on here. Well, what I'm saying is, like, don't need to know the formula. I know I'm being a little cagey here. You almost certainly will not have to know the formula, but I'm kind of covering my base. The formula is in this book as something you should know. So technically, they could ask you a question where you have to do it. But I'm saying, even if a quadratic question like this comes up, there will almost certainly be, I know, very cagey, there will almost certainly be another way to do it, which involves plugging in your own numbers or testing the answer options. So if you want to be 100% sure, memorize the formula. If you want to be 98 to 99% sure, probably not. Okay. Let's see what the next one was. It was 10, 15, A and B, and 21. Okay, so let's look at 10. If the ratio of 2x to 5y is 3 to 4, what is the ratio of x to y? Where can I get this out? I'll start with this. What is a ratio? I'll get a definition on that. How would you define a ratio, Laura? And Laura wrote fraction. And by the way, Laura, if you want, if you're comfortable, feel free to send your messages to the group, like everyone's that people can see. You don't have to if you don't want to. But fraction is a great answer, or I should say, a fraction is one way to express a ratio, and in this case, a very good one. So when we say that the ratio of 2x to 5y is 3 to 4, Laru, are you comfortable with me writing 2x over 5y equals 3 over 4? Does that make sense? Or maybe you already got that far on your own. 2x, great. 2x to 5y is 3 to 4. And I don't know if Laru, you've gotten this far in the videos yet, or if S, you remember what I call this. But when you see this setup, something over something equals something over something else, I call it the Nike rule. Because when you see it, you should just do it. And what do I mean by it? I mean cross multiply, right? When I have two fractions set equal to each other, I'm not going to stick around and wonder, oh, what's the most efficient way to manipulate this? I'm just going to cross multiply, because almost always that gets me where I'm going. So what I get here is 2x times 4. So 8x is equal to this cross multiplication, 3 times 5y, or 15y. So far, so good, Laura? Now, the last step, that's first you got. Okay, so you got this far. The last step is, what do I want? What's my North Star? Well, I want a ratio of x to y. And let's go back to our original definition of a ratio. It's a fraction. What can I do? I'm being sort of open-ended here. What can I do to this equation so that I get x over y equals everything else? Just a little bit of algebraic manipulation. I'll divide both sides by y, right? The cardinal rule of algebra is I can do anything I want to both sides, right? Because if they're equal values, I can do the same thing to both sides. So I'm going to divide both sides by y so that I get what I want here. And then I'm going to divide both sides by 8, because that's going to cancel that out and put 8 on the bottom. And so what I get is x over y equals 15 over 8. Let me know if that's okay, Laura. Excellent. Then 15. It was just 15B, right? Go back to the thing up there. Oh, A and B. Okay, got it. So a group can charter a particular aircraft at a fixed cost. If 36 people charter the aircraft rather than 40 people, then the cost per person is greater by 12. So the first question is, what is the fixed total cost to charter the aircraft? Um, again, let's sort of go to the sum, the total, divided by the number of people equals the average amount per person, except everyone here is paying the same. I'll save my wild idea for this in a minute. But for now, let's say this. We're considering two different possibilities. There's the first one, so where 36 people charter the aircraft, and the second one, where 40 people charter the aircraft. So I'll fill in the numbers here. This is 36 people, and this is 40 people. Now, Laru, what does not change from the first case to the second case? What stays constant? The fixed cost of the plane, right? It's not like we get a discount for having more or fewer people on the plane. So the fixed cost of the plane, the sum, stays the same. But these averages are different. Which one is higher? I'll call it like the left one or the right one. Which average cost is going to be higher? Which plane would you rather fly on? Right, it's going to be higher on the left. So basically, let's call this the average when there's 40 people. And this is the average when there's 36 people. But I can rewrite this as the average when there's 40 people plus 12, right? This side is going to be 12 greater than that. I'll pause right there and ask if that makes sense. Setup's the hardest part, of course. Great. And I'll throw a wild card way to solve this in a minute. Okay, so Laru, how many equations and how many variables do I have here? Two equations, two variables. And what sort of like trigger does that set off when I have two equations and two variables? S, feel free to hop in on this one. Yeah, isolate one to solve the other. I'll just give the buzzword systems of equations. This is a system of equations. Whenever you have two variables and two equations, you can always isolate one and solve the other. Which one would you like to? Well, I'll make this. I don't want to make you keep typing here, Laura. But let's this one's already isolated, right? So let's just call A40, and we could name these different variables if you wanted to. We could call this just X, but A40 is equal to S over 40. So I'll plug this in for that. What I get is S over 36 is equal to S over 40 plus, wait a minute, sorry, what did I do here? Oh, I'm sorry. Yeah. S over 40. There it is. S over 40. Sorry, this pen has a mind of its own. S over 40 plus 12, and now I can solve for S, right? Got to do a little bit of algebra, right? I'm not even going to say algebra, arithmetic. Multiply both sides by 40. So I'll multiply this by 40. multiply this by 40, that cancels that out, and I'll multiply that by 40. So what I get is 40s over 36 is equal to s plus 480. Someone hop in if I'm messing up my algebra. I don't think I am, though. And then we can simplify this down if we want to. You have your calculator, so that's always an option. This becomes 10 over 9s equals s plus 480. So I could subtract 9 over 9s on both sides, right? So that this becomes 1 over 9s equals 48, and s is just going to be 48 times 9. I know I zipped through the manipulation there. If anyone wants to see that a little more in detail, let me know, and I'll run back through it. But the setup really is the most important part. And so whatever this equals, 18 less than 50, I think. So 18 less than 450 is 432. No, that's not right. Yeah, 432. Yep, there it is. So that's the fixed total cost. And then, of course, the cost per person with 40 people is we just divide that by 40. Any questions on that? It's a doozy. How do I know when looking that this is set up like the SNA formula? Great. And, the SNA formula is pretty intuitive. And I don't mean like that to say like it's easy and it should just pop in, but the SNA formula describes something um that we kind of use every day, which is like this is the total, this is the number of people, so this is the price per person. I just used the SNA formula frankly because it was like right in my head, but I bet, LaRue, if I asked you like how do you calculate the cost per person, you would say, well, you take the total and divide it by the number of people. Um, but recognizing that it's a system, I would say is the big one on this. Even if you don't call it the SNA formula. I kind of regret even calling it the SNA formula because SNA is like the average thing. Um, okay. Now, here's my wild card way to solve this. And this is a good sort of guiding principle for word problems. Word problems take place in the real world. What do I mean by that? I mean, if I just threw, if I, and I'm not used to flying on chartering private planes, but if I said, what do you think is a more reasonable dollar amount to charter a plane? $4 billion or $1,000, right? You have sort of like a reference point. It's probably not going to cost $4 billion to charter a plane. So, as crazy as this sounds, what you could do if you're completely lost, if you can't think of any way to do it, is start guessing around. Here's what I mean by that. I'm going to start by just throwing out a number. Actually, I'm going to ask you, Laurie, to throw out a number. I know we've already done this, but how much do you think it costs to charter a particular aircraft? $100. Seems a little low. Why would anyone fly commercial? But that's a reasonable number. So let's just test that. How much does each person pay with 40 people? How much does each person pay with 36 people? Take a look at that in your calculator. 2.5 and 2.8. Now, we want this to be a difference of $12, and we're not anywhere near that, right? So throw out another number. Right? And then I'm not going to like go through it all, but I'm just pointing out you start to zero in on the right answer pretty quickly because this one would end up being too big if we did 500. And then you probably go to like, I don't know, 450. It's still too big. Or 20, but it's not a crazy amount of time to spend because the arithmetic is so easy and you have your calculator there. Just throwing that out as an alternate way to do it. Okay. S asked question, more math questions. Great, of course. Essay question, advice for prompts, including claim and reason. I'll address that when we do that. Also wanted to ask you, no, do we have our school codes memorized for sending GRE scores immediately after the exam, or does ETS provide them? It's a great question. And I want to be careful about giving you advice on like what to submit or if to submit. There should be a way to like search for the school or designate it. I don't want to make you worry about memorizing the code. Um, if you want to be super safe, memorize the code. I'm almost certain they let you search by school. Um, but double check. You can even ask. You can ask at the testing center when you check in, or ask the proctor when you're taking it at home. Okay, great. So we'll finish up. I think you only had one more question. 21. Well, I want to make sure we get to S's questions here. Uh, yeah, well, let's come back to this one, Laura, if we have time. Um, but let's go to S's math questions, and then if um we have some time, I'll ask you, S. Do you definitely want to make sure we get to that essay question, or would you rather prioritize math?
I would rather prioritize math.
Okay, great. So let's start there.
Thank you.
And I'll zip through these. I know I'm pretty talkative. Um, I do it because I love the GRE. Right? I just love talking about the GRE. Okay, so this is asking for the perimeter of the polygon. Immediately, the thing that pops out to me is this 45, 45, 90. And that's one of our special right triangles, right? Immediately, I know this is going to be x, x, x root 2. Now, I also know that this distance is 12. So x times the square root of 2 is equal to 12. Now, it's asking for the perimeter of this shape. So I need to figure out what x is. X is equal to 12 over the square root of 2. Now, here's where we get into a little bit of math nerddom. By convention, you are not supposed to have a radical in the denominator of a fraction. So if you do a ton of work on a geometry question and you end up with an answer like this, but you don't see it in the answer options, it's because they've done something called rationalizing the denominator. And if what I'm about to do stresses you out too much, or you're worried you won't remember it, just use decimals, right? Like just ask your calculator, what's the value of this? And you'll get a decimal value. So 12 divided by 1.41, whatever this comes out to on your calculator, is the decimal value of x. The other way, the sort of like proper way, but please don't be shy about using decimals, is to multiply the top and bottom by a root 2. Because when we do that, we get 12 root 2 over the square root of 2 times the square root of 2, which is 2. So I get 12 root 2 over 2, which is 6 root 2. So x is equal to 6 root 2. Now, this is a distance of 5. This is a distance of 12. This is a distance of 5. So right there, I have 22. Given that X is I'll call it like kind of a freakish number, I'm probably looking at C or E, right? I mean, the only way for this not to happen is if somehow magically these two add up to an integer. The other thing worth noting is that because I'm talking about a 45-45-90 right triangle and not a 30-60-90 right triangle, I'm leaning more towards this one because it has a root 2 in it instead of a root 3. So I can put everything on the left here to the side and just sort of eyeballing it, say, well, it's 22 plus something. And so these are out. And that something should probably be a root 2 instead of a root 3. Now, to be exact, since each x is 6 root 2, it's going to be 6 root 2 plus 6 root 2, and that's going to be 12 root 2. Great. Got this process elimination, but really wanted to see the proper method. Yes, great. So, and I'll say that process elimination, if you did what I just said there, like that's a perfectly valid way to solve this problem. And I'll just sort of like button that with the GRE does that on purpose, right? They realize that not everybody is, a geometry ninja and knows all their rules cold. So they want to give you this other way to solve it. That connects back to the point I was making about quadratic equations earlier. All right, on we go. Next question from Sarah here. Oh, I remember this one. Yeah, Judy and Greg. Let me just share this. Blow that up a little bit. Boom. Okay, so Judy drove 20 miles from her house to a theater at an average rate of 50 miles per hour. Greg drove from his house to the theater in 1/3 of the time it took Judy. They both arrived at the theater at the same time. Judy left her house at 7:30. When did Greg leave his house? Immediately, I see distances, I see speed, and I see time. So I kind of jot down for myself distance equals rate times time. And because I'm dealing with two characters, I might say distance Judy equals rate Judy times, not equals, times time Judy. And distance Greg equals the rate of Greg times the time of Greg. Okay, so let's fill in what we know. Judy drove 20 miles. Well, that's nice. Distance of Judy is 20 miles. From her house to a theater at an average rate of 50 miles an hour. So the rate is 50. Well, now that we're kind of here, let's just solve Judy's time. Judy's time is 20 divided by 50. Now, units matter. We're talking about miles per hour. So this is going to give me 0.4 hours. Is that 40 minutes? It's not. Careful of that mistake. 0.4 hours is 4/10 of an hour. And if I like interned at a law firm one time, and in law firms, it's all about billable hours, right? And you had to keep close track of your time, and they did it in tenths of an hour. So the kind of little hack is every tenth of an hour, every 0.1 hour is 6 minutes. So 0.4 hours is 24 minutes. So Judy's time is 0.4 hours or 24 minutes. The other way I could get that, of course, would be to multiply 0.4 times 60 minutes in 1 hour. Okay, well, if Judy left her house at 7:30, that means she arrived at the theater at 7:54. We want to know when Greg left his house. Well, Greg got there in 1/3 of the time. So that's 8 minutes. And that's our answer right there, right? If Judy left her house at 7:30, Greg arrived at the same time, but he only spent 8 minutes. That means he left 8 minutes earlier than this. So 46. Is this, I assume this is the correct answer, S, right?
Yes,
Right. Right.
right on. Thank you.
And now, a more strategic point about this one. It's long. So, like, conceptually, when it comes down to it, not a terribly difficult question, but very labor intensive. It's going to take time to like wrap your head around this. And I mean, I'm operating with a little bit of an advantage in that I've seen this question a million times and I knew where it was going. But I'll be the first to say, like, this one probably would have taken me 1.5 to 2 minutes if I had seen it blind. And that's because it's so wordy. I would probably save this for the end, right? The ones that you want to do like first and quickly are the quant comparison ones because they're the nice thing is you can be wrong fast and it's not going to take away time. But let's say I'd gone down this rabbit hole. I poked around. It took me 4 to 5 minutes, and then I still get it wrong. That's a pretty big waste of time. So don't even go down the rabbit hole. Just say this might be an easy question. It might be a hard question, but it's a long question. So I'll save it for the end. All right. Moving right along here. Interesting. Yeah, probability. These are good. Stop sharing this one. Actually, I'll close that. Start sharing that one. Probability experiment. Probability that events E and F will occur is 0.42. The probability that E will occur, or 0.58. This is an example of, and I know it doesn't seem like it, but it's an example of overlapping sets. I have these two events. I don't know if they're independent, mutually exclusive, whatever. But basically, there's the probability that E happens and the probability that E doesn't happen. That's E and not E. The probability that F happens and the probability that F doesn't happen. Now, I'm told that the probability that both events happen, that E happens and F happens, is 0.42. Well, what is the probability of what do all the probabilities need to add up to in the end? They need to add up to 1, right? Everything needs to add up to 100%. It wants to know the probability that E will happen. So it's basically asking for this. Well, it could be 0.58, could also be 0.59, could also be 0.57, depending on what this mystery cell is right here. And because I don't have that information, I can't know. So overlapping sets apply also when you have, call it overlapping sets and overlapping probabilities, two events that are interacting in some way. And slow me down, of course, if I'm going too fast here. Just trying to get through as much as we can. So this next one is an average one. Interesting. That's a good one. For the 3 numbers in a list, the average and the median are equal to 8. Okay, so first off, there are only 3 numbers. So this is manageable enough to kind of like play around with by testing our own. That's my first impression. The greatest number in the list is 10 greater than the least number. What is the greatest number in the list? Um, S, throw out a number here. Any number.
12.
12. So I'm going to say that the greatest number in this list is 12. What is the least number in the list then?
2.
2, and the middle number has to be 8, right? That's what they said. The median is 8. What does this add up to?
22.
Divided by 3?
Mm. 7.3 repeating.
7.3. So were we too big or too small?
Too small.
Too small, but not terribly too small. 8 is going to stay where it is. Maybe we go, well, you tell me, where do we go from here for these two numbers?
We can try 13.
Sure, 13 and 3. How does that work out for us?
24 divided by 3 is 8.
There it is,
Mhm.
right?
Yes.
We could be algebraic about this if we wanted to. We could call this x. We could call this x minus 10 and say something like x minus 10 plus 8 plus x over 3 is equal to 8, right? The sum of these divided by the number is equal to the average.
Mhm.
But I don't know. I kind of like plugging
Yeah.
around person.
Yes.
Yeah. Um, yeah, don't never poo-poo sort of like a shot in the dark because you can always it's like I've I don't have much experience like launching fireworks or anything like that, but I know like if you're trying to like hit something with ballistics, you sort of like benchmark. You're like, oh, is that too far or too short? Um, okay, we did that one, and then triangle DEF. Measure of angle D is 25 degrees. Measure of angle E is greater than 90, which one could be the measure of F. Immediately, we're dealing with triangles and we're dealing with angles. So the number 180 pops into my head, right? I know that these three angles need to add up to 180. So let's call that DEF. Not at all drawn to scale, I know. But if that one's 25 and this one is greater than 90, what happens if it's 91, right? Well, if it's 91, then this missing angle is 180 minus 91, 89, minus 25 is 64. And if it's 92, this would be 63. And if it's 93, this would be 62, right? The idea is it's a zero sum game. I only have 180 degrees to distribute. So the maximum that this angle could be, since this one is 90 plus, every angle I give to E is one taken away from F, and that means that there's a cap on F. F cannot be 70 degrees. Because if F were 70 degrees, this would be 95 and this would be 85, which breaks the rule. But you could, if you really wanted to, test all of these numbers and make sure they work, but you don't really need to because it's a limit, right? F has to be below 60, 65 degrees to be exact. So it could be 64.9, but the line in the sand that we draw is right there. Let's do, I think you have one more math question here, Sarah. and then I can quickly address the question you had about essays.
Thank you so much.
Yeah, yeah, yeah.
Awesome. I know I sent a lot over.
No, no, no. Standard deviation. And so the question is, if they were not five apart, then how do we solve? I'm going to give a little bit of a cop-out answer here and say they probably wouldn't have you do that because that you are not required to know how to calculate the standard deviation. Or if they weren't five apart, there would probably be some other indicator of which one is greater. But let's say we'll do this question here. So we're given two lists, 0, 5, 10, 15, 20, and 5, 10, 15, 20, 25. We want to know which standard deviation is greater. And yes, they are equal because the way to conceive of standard deviation, it's really frustrating because they want you to understand the concept. They don't need you to know how to calculate. The way to conceive of standard deviation, though, I would say is the diversity spread of a list. So maybe like combine those two together, the diversity and spread of a list. These two lists are equally diverse. Oh, that's weird. Sorry. These two lists are equally diverse and equally spread out. Now, that's not a perfect definition of standard deviation, but it's a good working definition. If this had been 26, then you could definitely say that quantity B is greater.
Makes
Yeah, yeah. Okay, so let's talk about that question you had about the essay. Let me pull that up here.
Yeah, so I think it's less common to see a claim and a reason in the prompt.
Mhm.
And I'm just curious if, I mean, I would assume you would need to use the reasoning while agreeing or disagreeing with the claim.
Mhm.
But I'm just curious if you have any other advice for how to tackle those.
Yes. Now, just to confirm, did this question come from ETS?
Yes, it was in the issue pool PDF.
Right. Just want to make sure. So, I would treat it just like any other essay. They're like labeling it, so that's like a nice favor to you. But this might as well say governments must ensure their major city receive support they need in order to thrive because, and then this is just your standard essay. Um, and so you have the essay template, right? S.
Yes.
That will work for this because you're coming up with a point of view and you're providing examples to support that point of view.
Mhm. Okay,
Yep.
sounds great.
Um, all right, great. So knock 'em dead. I know you're taking it today, S. Let me know how it goes.
Thank
Um,
you.
and LaRue, feel free to reach out with any other questions. And for anyone else watching, thanks for